Zahra Afghani with Namshad from Khalid High School Tehran. And we're now here to talk about our project, the role of zinc ferrites and ionized nanoparticles to remove contaminants from contaminated water. As we know, water pollution is one of the most significant issues facing us these days. We use the ionized and zinc ferrite nanoparticles in the extraction of methylene blue dye in water, and also investigated the effect of three items, different time durations, environments, and concentrations.
One of the materials we use in this project is ultraviolet spectroscopy. This device can obtain the color absorption of methylene blue in the range of 200 to 800 nanometers. We also use scanning electron microscope to measure the diameter of synthesized nanoparticles.
To add more, we use the time absorption spectrometer to measure the quality of pigments such as zinc.
We synthesize ionized nanoparticles with the core precipitation method. After calculating, we use certain amount of raw materials, which include sodium chloride and iron dihydrate and trihydrate. Zinc ferrite nanoparticles were prepared by soldier combustion method. Iron chloride hexahydrate and zinc chloride were employed.
Figure 1 depicts excited patterns of the pure zinc ferrite. Both excited patterns are similar and demonstrate characteristic deflection peaks on an autohombic spinel like the zinc ferrites. So for having a control samples, after making the methylene blue solutions, the maximum absorption rates were read by a spectrometer. Then we had our synthesized particles put into minutiae environments, and after 24 hours, the highest absorption rates were again investigated.
As I said before, SEM is used to measure the size of synthesis particle. The image displayed that the size of zinc ferrite nanoparticles were about 17 nanometers, and the size of ionized nanoparticles were 38 nanometers. Because of the small size of particles, the surface to volume ratio was increased. To evaluate the concentration of dye, a specific amount of photocatalysts and absorbents were added to three different concentrations: 10 ppm, 20 ppm, and 30 ppm. This diagram demonstrates how zinc ferrite affects all concentration and destroys the dye. The peak was in 650 nanometers and the absorbent was mostly 2.5 AU. You can observe that ionizers has also been able to attract the dye in all concentrations, although the peak of absorbents were about 2.2 AU.
So how do we see absorption in different environments? The specific amount of the synthesized particles were poured into the pigment solution with pHs 3, 7, and 13. Due to diagram 3, the effect of acidic, neutral, and alkaline environments of the dye absorption by ionized nanoparticles, we can observe the absorption rates in these three environments. Our sample's maximum absorption rate with pH 7 was about 1.5 AU. While looking at the gray line, ionized nanoparticles has worked inefficiently because the highest absorption rate was more than 2 AU and more than our samples. By the way, in pH 3, the absorption of ionized was significantly constant, and the rate was less than 0.5 AU. Also, diagram 4 shows the effect of different environments in the dye absorption by zinc ferrite nanoparticles. As you can see, zinc ferrite wasn't able to remove dye while in acidic and alkaline environments. The highest rates in acidic and alkaline environments were about 2.5 AU, but in neutral environments, the dye was highly removed and the rate was less than 0.5 AU. In order to investigate the time effect, a specific amount of the absorbent and photocatalyst particles were poured into the solution in three different time durations, 24, 48, and 72 hours. Then the maximum absorption rates were read. Diagram 5 shows the way that zinc ferrite has affected methylene blue dye in 24, 48, and 72 hours. The synthesized ferrite was able to be active during these three consecutive time durations. Diagram 6 indicates the rate of dye removal by ionized nanoparticles in different time durations. Ionizing has studied properties as tempests as well as ferrites. These nanoparticles have shown a better performance than zinc ferrite nanoparticles, so both synthesized particles were able to absorb and destruct the dye over time.
To investigate the absorption of heavy metal with the AAS, lead was chosen as a pollutant, since it's an important and significant heavy metal in water. According to diagram 7, both materials had a great effect in removing heavy metal, but zinc ferrite had a far better response than iron oxide.
In the end, we'd like to have some advice needed for other researchers, such as using green synthesis for the mentioned materials and also other dye for the solutions. The Global Youth Technology and Science Bowl competition was truly a fantastic experience for us. With sincerely official consideration, thank you.